Okay, so thanks everybody for joining us. This is the All Hazards Consortium webinar. I'm Dave Jones, and we're joined by Dr. Michael Brennan from the National Hurricane Center. He's the branch chief of the Hurricane Specialist Unit to tell us a little bit about what the Hurricane Center is doing this upcoming season, particularly about the new products that are going to be available as they put those together when storms form. So, Michael, thanks so much for joining us.
Yeah, hi, Dave. Thanks, everybody. Glad to be here. As Dave mentioned, I'm going to cover some of the new products we're going to be putting out for this current hurricane season. Talk a little bit about how they can be used to help make decisions in advance of a storm, and also start off with a review of some of the challenges from last hurricane season with some of the particular storms we had, and then talk a little bit about how our forecast did. So, looking back on the 2019 hurricane season, it was pretty busy from an overall storms perspective. We had 18 named storms. 6 of those went on to become hurricanes, including 3 major hurricanes. So we had 12 tropical storms that did not go on to become hurricanes. We had a pretty fair number of short-lived, relatively weak storms in the basin, but we had some very impactful systems. Obviously, everybody remembers Hurricane Dorian that affected the northern Bahamas as a Category 5 hurricane, produced a catastrophic wind and storm surge there, and especially on Grand Bahama and some of the other islands in the northwestern Bahamas there. Hurricanes Umberto and Lorenzo were also in the basin and did affect land areas. Umberto affected Bermuda, Lorenzo affected the Azores. And there were 6 systems that affected the U.S., including Dorian as a hurricane. It made landfall on the Outer Banks of North Carolina, and Barry, which made landfall as a hurricane in Louisiana. So thinking back to the 2019 season, you think about which hurricane in 2019 caused the second most fatalities in the basin and the most fatalities in the United States. So from looking at this map, you might think it was one of these other storms that was here in the western part of the basin that got relatively close to the United States. But in reality, it wasn't. It was Hurricane Lorenzo that formed out here south of the Cabo Verde Islands and didn't get any farther west than about 45 degrees west. It was about 1,500 miles away from the United States, and then recurved and passed near the Azores as a hurricane and underwent extratropical transition over the northeastern Atlantic. But Lorenzo caused a lot of fatalities. It caused 11 deaths due to the sinking of the tugboat Bourbon Road out here in the eastern Atlantic. There were 3 of that crew that were rescued. But additionally, there were 8 rip current fatalities in the United States, from all the way from Florida up to Rhode Island. There was a cluster here along the North Carolina coast. So just a reminder that storms that even don't make it any closer than 1,500 miles away from the U.S. can still have these sort of distant impacts, especially from rip current fatalities, which can happen when the weather is otherwise quite good at the beach along the U.S. East Coast in this particular case. Looking back at the track errors of last 2019 hurricane season, the average track forecast errors in the Atlantic Basin actually went up a little bit in the short range here at 24 and 48 hours. But there's still a very significant long-term downward trend, looking at the long-term error trends at all of the forecast lead times, particularly out here at days 3, 4, and 5. Another way of looking at how the errors have evolved at time is by looking at average errors by decade for track. So here in the purple line is the average track forecast error in the 1960s, and blue is the 1970s, green is the 1980s. Then we move on to the 1990s, the first decade of this century, and then the 2010s. And you can see that, the track forecast errors didn't really change very much all the way through the 1980s, but then there were big improvements as we got into the 1990s, and those big improvements have continued through the first 2 decades of this century. You can see now that the average track forecast error, say at 3 days, now is about 100 nautical miles. In the 1970s, it was somewhere around 375 or 380 nautical miles. So there have been tremendous improvements there. And these improvements have largely been driven by advances in numerical modeling. The numerical weather prediction models that forecast weather across the globe do a pretty good job of forecasting the sort of large-scale patterns in the atmosphere. And that's what generally controls hurricane track. So as those models have gotten better, they've run at higher resolution, use more sophisticated representations of the physics in the atmosphere, and have a lot more data going into them. We've seen great improvements in forecasting of hurricane track. Now, not every storm is the same, though, even within a given season. In 2019, the track forecast errors for the first several storms of the year, all the way up through Melissa, were actually pretty good. The mean 2-day track error up through Melissa for NHC's errors was about 55 nautical miles, which is below this 5-year average of the previous 5 years, which was about a little over, closer to 60 or 70 nautical miles. So of these first few storms, we had a lot of storms with small errors. Aaron and Gabrielle had errors above the 5-year mean, but all the rest of them were below. However, when we got to the late in the season, we had 2 storms, Pablo and Sebastian, particularly Sebastian, that were a high latitude storm. Late in the season, the NHC and the forecast models really struggled with forecasting their track. They had difficulty with the structure of the storm, how it was going to interact with the faster mid-latitude flow. And you can see that just those 2 storms contributed significantly to the errors for the whole season. And the mean 2-day track error for the whole season now went up to 75 nautical miles, just on the basis of those 2 storms, when it would have been about 55 nautical miles without them. And in fact, we made some of the largest 2-day track forecast errors for Sebastian that have happened in the last 25 or 30 years. So there can still be situations where the track forecast can be very difficult, but on average, they continue to get better. This is a similar chart showing the decadal progress in intensity forecast error. And, for many, many years, and almost up until the last few years, we've always talked about how the track forecasts were getting better, but the intensity forecasts really weren't getting any better. And you can see here that over from the 1970s all the way through the first decade up through 2009, the intensity forecast errors were getting better, but by very small amounts. But we saw a pretty significant improvement in intensity forecast error in the last 10 years. For 72 hours, we've seen the average error decrease from somewhere around 18 knots to maybe around 14 knots. So that's a pretty big change, and that's the first real improvement we've seen in intensity forecast, in reducing intensity forecast error. We're certainly not where we need to be, or not where we want to be. We still struggle with rapidly intensifying storms and can still have situations where we have very large intensity forecast errors. But we are seeing some progress now through better numerical modeling, better data getting into those models, and better understanding of sort of the environment that's favorable for quick strengthening storms. Going to Dorian now. Dorian had a lot of challenges associated with it, all the way from its formation to its early track and intensity forecast to the later intensity forecast as it got near the Bahamas. One example of how the track and intensity were tied together was that, as soon as Dorian moved across St. Lucia, the center sort of reformed farther to the north. And initially, all the track forecast guidance had this system moving, west-northwestward, near or over Puerto Rico, or even portions of eastern Hispaniola, which could have resulted in significant land interaction. And while at this point in time, we were forecasting the storm to go near Puerto Rico and Hispaniola, we had a tropical storm warning and hurricane watch out for parts of those islands. Didn't have anything in effect for the Virgin Islands at this point, early at the late morning on the 27th of August. So then Dorian reformed a little farther to the north, and then it ended up strengthening more and ended up moving over the Virgin Islands as a hurricane. And we had a sort of a short fuse hurricane warning for the Virgin Islands, had a wind gust to 111 miles per hour there in St. Thomas. And what you'll note here is that the track of Dorian actually moved outside of the entire guidance envelope. Lots of people tend to think that if the guidance is in really good agreement, that the track forecast errors are automatically going to be on the low end. And that's not always the case. Sometimes all the track model guidance can be incorrect and can still look, the forecast can appear to be very certain, but that doesn't always play out that way. There were some difficulties in forecasting Dorian's intensity as well, due to that potential land interaction. This is the intensity model guidance that we had for the 18Z forecast cycle on August 27th. The actual intensity of Dorian is shown here by the white hurricane symbols every 6 hours. And these colored lines are the actual model intensity forecasts, along with the NHC forecast. You can see that most of the guidance was showing a steady state or even weakening storm during the first 2 to 3 days of the forecast period, as Dorian was expected to move near land or over land. And then some recovery, but only gradual re-strengthening as we get out to 4 and 5 days. You can see that the NHC forecast had a 60-knot system in 5 days, and the storm ended up being 160 knots. So there was a 100-knot intensity forecast error in 5 days. And none of the models actually even had a major hurricane. Even only just a couple of them had the system strengthening to a hurricane within the 5-day forecast period. So why were the intensity errors so large? Well, if you look at the track model guidance, again, at this point in time, now we're going back a couple of days to when the storm was farther east. You can see that all of the guidance, again, was showing this potential for land interaction. And that land interaction, especially with Hispaniola, can be very detrimental to storms and cause even complete dissipation or significant disruption that takes a long time for the storm to recover from. But in reality, you can see that Dorian moved well to the right of the track model guidance, missed Puerto Rico to the east, and then was able to basically take full advantage of this very favorable environment that it found here over the southwestern Atlantic as it approached the Bahamas. So we had some different scenarios with Dorian, sort of three different potential outcomes, all due to potential land interaction. The first scenario is that Dorian moves along the south side of the track forecast cone, a little to the left of the official forecast, and actually moves across Hispaniola. In this case, as I mentioned, the topography of that island could have resulted in significant disruption or even dissipation of the storm. Scenario number two is that Dorian moves near the official forecast and has some interaction with perhaps Puerto Rico and or Hispaniola. The result would likely have been some weakening or at least a pause in strengthening, but some time for re-strengthening because the storm wouldn't be as severely disrupted as it moved into the southwestern Atlantic. Scenario number three was that Dorian moved north of the cone and avoids all significant land interaction, and this is indeed what happened. And because of this, there was an intensifying hurricane that moved into the western Atlantic and then rapidly strengthened as it approached the Bahamas. And that's what we saw. We saw basically Dorian go on and become a Category 5, and sort of a worst case, certainly a worst case scenario for that part of the Bahamas there. So now we'll talk a little bit more about the tropical cyclone products, watches, warnings, and hazard information that's available from NHC. So when you think about a hurricane and you close your eyes, what do you see? And most people think about the wind hazards, but in reality, the water hazards are the most deadly and typically have the ability to result in the largest loss of life, not only near where a storm potentially makes landfall, but hundreds of miles inland and days later through inland flooding and rainfall. But the five main hazards are storm surge, inland flooding, the wind itself, waves and rip currents, and tornadoes. Now, if you look at the causes of direct deaths from tropical cyclones in the Atlantic Basin here in the United States in the period from 1963 to 2012, so these are direct deaths, fatalities that are directly attributable to the forces of the storm. You see that storm surge is responsible for almost half of those fatalities, 49%. Rainfall flooding is another 27%. Another 6% die in those rip current or rough surf conditions. 6% more perish in offshore incidents, marine incidents. Then the remaining 11 to 12% are due to wind and tornado impacts. So while the wind typically gets the most attention, it's the storm surge and the rainfall that historically cause the largest number of fatalities. In particular, the last few years, 83% of those fatalities from 2016 to 2018 were water related, and most of these were actually due to inland flooding. Only 4% were storm surge related. So we've had a big uptick in the number of inland flooding fatalities, or big in terms of the percentage of deaths here in the United States in the last few years. And we've certainly had some very impactful rainfall storms from Harvey to Florence to Imelda. But there were even rainfall flooding fatalities in storms like Michael as well. The flood-related fatalities have largely been due, more than half of them have actually been due to, have been vehicle-related. So we're losing people who are driving into areas where there's flooded out roads or around barricades. And so this is a big messaging challenge we have as a community, is how to remind people and reinforce to people that you don't want to be out driving in your vehicle in these types of flooding conditions, because you could easily lose your life. We've also looked at the so-called indirect death causes, and these are fatalities that aren't directly due to the forces of the storm. So these aren't people who drown or are killed by wind-borne debris or die in a rip current, but these are people who die from other causes that probably wouldn't have happened if the storm hadn't occurred. So these are people that die from heart attacks. You see 31% of these indirect deaths are due to cardiovascular incidents. People die during evacuations, through traffic accidents. People die in electrical fires, in carbon monoxide poisonings. They die from accidents, falling from a roof or a ladder. They die due to lack of medical equipment, due to power outages. So these fatalities are now becoming almost as large, or even larger in some cases, than the direct fatalities from storms. And while people are surviving the direct forces of the storm, they may be left in a very vulnerable position after the event, where there's widespread power outages, there's no emergency services, there's no medical equipment available. So anyone who finds themselves in a compromised position, either through some sort of medical condition or accident, is now left in a place where they can't really be helped. And those fatalities have become a bigger part of the loss of life in hurricanes and tropical cyclones in the United States in recent years. And these indirect fatalities are disproportionately affecting older parts of the population. 58% of the fatalities are occurring to people who are over 60 years old, 28% are affecting people between 31 and 60, and 14% are affecting people less than 31 years old. So there's basically 8 times as many victims over age 60 as there are under the age of 21. So again, that speaks to some of the potential additional medical complications that older segments of the population can have, vulnerability again to being left in a situation where there's very little in the way of medical or other infrastructure behind after a storm. Storm surge itself, as I mentioned, has the greatest potential for loss of life on a widespread scale. You know, Katrina killed over 1,200 people from storm surge. Sandy killed over 70. Tremendous amounts of damage can be caused as well. Large-scale, flooding, home destruction that can occur in these large-scale storm surge incidents. Freshwater flooding, you're talking about flash flooding, river flooding that can occur days after and hundreds of miles away from the initial landfall location. This can occur on very short time scales with flash flooding that can occur as the water's falling or within a few hours. And then also you can have significant river flooding like you saw in a storm like Florence that's occurring days to even more than a week after the storm moves past. The wind damage and the wind threat can be categorized pretty easily by the Saffir-Simpson scale that runs from Category 1 all the way up to Category 5 hurricanes, with Category 3, 4, and 5 being major hurricanes. But again, it's important to remember that the Saffir-Simpson category only talks about what the wind damage potential is. It doesn't really touch on the potential for storm surge, and certainly not the potential for rainfall flooding, which is almost entirely disconnected from how strong a storm is at landfall or even later on in its life cycle. Tornadoes are spawned frequently by landfalling hurricanes. About 70% of them produce at least one tornado, 40% produce more than 3. Occasionally, storms will produce these large tornado outbreaks. This is Hurricane Ivan from 2014 that produced over almost 120 tornadoes, extending all the way from the southeastern U.S. up into the mid-Atlantic states. And occasionally, these, again, prolific storms can produce tornadoes hundreds of miles and days away from the initial landfall location, especially for storms that make landfall on the Gulf Coast, and that favorable right semicircle of the storm remains over land as it moves up into the eastern United States. So NHC's tropical cyclone products are designed to provide the big picture information. We're following the storm throughout its entire life cycle, making a forecast of where the storm's going, how strong is it going to be, how big is the wind field, and then what are these sort of large scale impacts? Where is the worst storm surge, the worst wind, the worst rainfall going to occur? We provide probabilistic hazard information on things like storm surge and the chance of seeing tropical storm and hurricane force winds. And then the local impacts are really provided by local National Weather Service forecast offices around the country that can really get down to what are the impacts going to be at a community level, where most of those major sort of storm preparation, evacuation decisions are being made. The NHC forecast advisories are issued every 6 hours on tropical cyclones, so systems that are tropical depressions, tropical storms, and hurricanes. We also can keep issuing advisories on systems like a Sandy or Hermine now that are post-tropical, that are no longer tropical cyclones, but if they remain a threat to land, we can keep issuing forecasts for them, and we can keep up our tropical cyclone watches and warnings. We also now have the ability to issue forecasts and warnings for so-called potential tropical cyclones. These are systems that are not yet TCs, but they could bring the chance of tropical storm force into land areas within 48 hours. And this allows us to issue those watches and warnings with the appropriate lead time for systems that we used to have to wait to go on and become a tropical depression or tropical storm. We've used that very frequently during the last few years, and on average, it provides an additional about 17 hours worth of lead time for the watches and warnings. So we're making that 5-day track and intensity forecast. We're forecasting the size of the storm. How big are the tropical storm force winds out through 3 days? How big are the hurricane force winds out through 2 days? Our forecasts include the coastal watches and warnings, tropical storm, storm surge, hurricane for the United States and international areas. I mentioned that hazard information, again, that's really designed to be used by decision makers. What are the chances of seeing tropical storm force or hurricane force winds at your given location? When are those tropical storm force winds most likely to arrive? What is the storm surge potential for your area? What should you be planning for? The rainfall information as well that we get from the Weather Prediction Center. And then we also have our forecast discussion that lets the forecaster talk about their reasoning and confidence in the forecast, as well as the key messages that we put in the forecast and put in these standalone graphics like the one you see down here in the bottom right. These are sort of the 3 or 4 most important points that we want to get across about the storm. Again, large scale impacts. What are the potential hazards? What should people be starting to do in terms of paying attention, following the advice they're getting from their local officials? Now, reminder of the definitions of the watches and warnings. A hurricane watch means that hurricane conditions are possible within the watch area, generally within 48 hours. A hurricane warning means the hurricane conditions are expected somewhere within the warning area, generally within 36 hours. And it's important to note that the lead times, that 48 and 36-hour lead time, are tied to the arrival of tropical storm force winds, because once those winds begin, it's very difficult to make any additional storm preparations or evacuate at that point. The storm surge watch similarly talks about how there's the possibility of life-threatening inundation from storm surge, generally within the next 48 hours. And this warning is done on a very fine scale grid that allows us to sort of very particularly highlight those areas that have the possibility of life-threatening storm surge that might be separate from or extend farther out than the area that could see the winds associated with a hurricane warning, for example. The storm surge warning means there's the danger of life-threatening inundation from storm surge, generally within 36 hours. Again, that timeline is tied either to when the first hazard is going to arrive, whether it be the tropical storm force winds or the arrival of a water rise along the coast. And this is an example of the storm surge watch warning graphic. The warning shown here in the sort of dark pink and the light pink showing the watch. Talked about the potential tropical cyclones. I wanted to touch on that a little bit more. We've used them for 18 systems over the past 3 seasons, about 6 per year. You can go back to 2019. We used it for several systems. In Barry, it gave us 24 hours of additional lead time for when we issued a hurricane watch for the pre-Barry disturbance. This is what it looked like. It was still a potential tropical cyclone, but we were forecasting it to go on and strengthen to a hurricane before it made landfall in Louisiana. So we were able to get those watches out, the hurricane watch, the storm surge watch out in a timely fashion. Time of arrival graphics I mentioned. These are graphics that are really designed for decision makers who are sensitive to the arrival of tropical storm force winds. It takes into account the NHC forecast as well as the typical uncertainty in the track and the intensity and size of the storm. And there are 2 versions of the graphic that provide a earliest reasonable and most likely time of arrival of when tropical storm force winds could begin at a given location. So these graphics have now been around for about 3 seasons. They've been very popular, been very quickly adopted by the user community. The storm surge products, we have the storm surge watch and warning that became operational in 2017. Again, really to help us highlight those areas that are at risk of life-threatening inundation from storm surge. They're really designed to help aid in the public response and reinforce evacuation orders that are being made by local emergency managers. This is an example of the storm surge warning from Dorian that was in effect all the way from the Florida East Coast to southeastern North Carolina, then a storm surge watch for the rest of the North Carolina coast, Pamlico and Albemarle Sounds into the Hampton Roads area and lower Chesapeake Bay in southeastern Virginia. There's also the potential storm surge flooding map, which shows a reasonable worst case scenario, sort of a what you should plan for in terms of storm surge inundation for a given event. And that's, again, allows people to see what the reasonable worst case scenario is at their given location and what they should be planning for as they make their preparation decisions. We also have local National Weather Service Forecast Office hurricane impact graphics. And these are getting down to that more community level scale that are, again, showing the potential impacts for the various hazards, wind, storm surge, flooding, rain, tornadoes, that, again, are showing that consistent with the NHC forecast, but, again, a little local additional detail provided here by the local forecast offices. There's a variety of products available in GIS format from NHC at hurricanes.gov/GIS. That's sort of our GIS portal. It includes things like the forecast track graphic, the cone, the watches and warnings, the wind watch warning breakpoints, the initial wind field and forecast wind radii, the arrival times of tropical storm force winds, the wind speed probabilities, the graphical tropical weather outlook, and the preliminary best track. In addition, we have a lot of storm surge information. The P-surge output is available, along with the potential storm surge flooding map, that, again, inundation graphic that shows a reasonable worst case scenario at any given location of what people should be planning for, the storm surge watch warning, the communication points that define the storm surge watch warning, and then we also have a GIS RSS data feed and an active KML feed for Google Earth, and that's all on hurricanes.gov/GIS. There are other National Weather Service GIS products available through the weather.gov, and the WFO Hurricane Threat and Impact Graphic KML files are available at weather.gov/HTI, and other Weather Service GIS products are available at weather.gov/GIS. Now I'll get into the product changes for 2020. A reminder that the storm surge watch and warning for Puerto Rico and the U.S. Virgin Islands became operational in 2019. We didn't use it last year, so that's still sort of a new product for this season. We have a new experimental peak storm surge forecast graphic that shows is a graphical depiction of the storm surge forecast values that go in the public advisory. We also have a new 60-hour forecast that is in the forecast. The NHC official forecast now includes a 60-hour position, intensity, and size forecast. And then we also have some new local time zones in the Eastern Atlantic for storms that are affecting the Cabo Verde Islands and the Azores. So again, a reminder that the storm surge watch and warning expanded to Puerto Rico and the U.S. Virgin Islands in 2019. It'll appear on the NHC website at hurricanes.gov, just like a storm surge watch warning would appear for the U.S. Gulf and East Coast. There is no inundation graphic for Puerto Rico and the Virgin Islands in 2020, but the watch and warning will be available. Here's a look at the experimental peak storm surge forecast graphic. So as I mentioned, it's sort of a large-scale look at the peak storm surge forecast values from the Tropical Cyclone Public Advisory. And this will be provided for the U.S. East and Gulf Coast, Puerto Rico, and the U.S. Virgin Islands when we have a storm surge watch or warning in effect. So it's the same numbers that have always been in the public advisory. It's an aerial threat. So it's an expected value that you would get somewhere within that specified area if the surge occurs at the time of high tide. So for example, between the Savannah River and Isle of Palms, if the surge occurs at high tide, you'd expect somewhere in that area to see 4 to 7 feet of inundation. Between Isle of Palms and Myrtle Beach, you'd expect somewhere in that area to receive 5 to 8 feet of inundation. It does include the impact of waves, especially for places with very steep bathymetry like Puerto Rico and the Virgin Islands. And we created this primarily for use in briefings, for use on television and social media applications, where you can't really zoom in and show it very well on, say, the inundation graphic, where you can really zoom down to a very small scale local level and see what your potential inundation could be. But that doesn't make for a very good overview graphic, and it's sort of hard to show in social media and on media briefings. So this is sort of a larger scale view meant for sort of a state to regional scale look at the storm surge, what we're expecting to see in terms of storm surge inundation. And this product is experimental this year. We've already used it for Cristobal in the Gulf of Mexico, and we are interested in your comments and feedback through the website. I did mention the new 60-hour forecast information. In the past, our forecast come out every 6 hours. They included forecast positions every 12 hours out through 48 hours, and then every 24 hours out to day 5. But we realized that that critical 2 to 3 day time period could use some additional information that allows us to show a little more detail in the forecast. As a storm is expected to make landfall between 48 and 72 hours, we can show more detail in the intensity forecast if we're expecting a change in track in that time frame. And it really helps us to improve the storm surge and wind speed probabilities, which are, again, those products that are helped to use to assess risk and help make decisions in storms. And this is what it would look like on the 60-hour cone graphic. You'll see that additional forecast point. But again, I don't want folks to pay too much attention to the details of that additional forecast information that has errors just like all the other ones. But the main reason we're doing it is because it really helps improve the probabilistic storm surge and wind speed information. We also have the new local time zones in the eastern part of the Atlantic Basin. So the issuance times of the products is not changing, but for products that use local time, like the public advisory, the discussion, the tropical cyclone update, and very importantly, the time of arrival graphics, For storms that are located east of 30 west and south of 25 north, they're going to use Cape Verde time. And for storms that are located north of 25 and east of 45, they're going to use Greenwich Mean Time. And this will provide, especially that time of arrival information, in time zones and in time using a time zone that's much closer to the local time in that part of the basin. So in the past, we were using Atlantic Standard Time that's off from Cape Verde time by 3 hours and off from Greenwich time by 4 hours. So it really allows a better timing information for these folks in the eastern part of the Atlantic Basin. Once storms get west of 30 west, south of 25 north, they'll be in the Atlantic time zone, and then the other time zones will be used as normal. So moving on to where we're headed to next. You know, we know we've made some strides, but we're not happy. We still know we need to improve the forecast more. We have a new round of funding through the Hurricane Forecast Improvement Project with new goals to reduce model forecast guidance errors, especially during rapid intensification, by up to 50%. We want 7-day forecast guidance that's as good as the current 5-day forecast guidance now. And we also want to improve the guidance that we have for these sort of pre-formation disturbances like the potential tropical cyclones, because if we're going to be issuing forecasts and warnings off of them and wanting people to take action, we need the guidance for them to be better. And we're thinking about how do we handle the potential tropical cyclone aspect for systems that aren't going to be a threat to land, but are going to potentially affect marine users. Storm surge, we're still working on modeling improvements. Talked about Puerto Rico, improving the modeling there, expanding to international and OCONUS areas, Haiti, the Dominican Republic, Guam, American Samoa, working in Southern California, adding waves to the slosh model. And another big thing we're working towards is extending that real-time storm surge guidance that's currently available about 48 hours before the hazard arrived out to 72 hours in advance, which is a much more actionable time frame for a lot of evacuation and preparation decisions. We're working on incorporating more social and behavioral science into our product suite. You know, for a long time, the products that we had and that we created as meteorologists were designed by meteorologists because we thought they were useful, and without really understanding how people consume and use scientific information or threat information about a storm. So we have a variety of social science projects going on that are looking at things from the forecast cone to how people assess information when the forecast changes, to how they understand numbers and sort of what the gaps are in the product suite and how people use information on the NHC webpage. So we hope to take the results from this and help you sort of craft what the next generation product suite will look like. So I'll just wrap up with some references to the NHC website, our product guide, some of the links to the GIS products, some hurricane preparedness information, and I'll wrap it up there. Thanks very much.
One of the questions that I had that came out of your presentation, I know we went over a couple before this, is the potential tropical development product. Is that when you issue that kind of product, does that impact your ability to predict storm surge and inundation? If the storm hasn't formed yet, how does that impact that prediction?
Yeah, well, for systems that haven't formed yet, there's usually more uncertainty in the track, the intensity, the structure of the storm. The model forecasts are not usually quite as good, and we typically make larger track forecast errors, for example, for these weaker systems than we do for, say, major hurricanes. But, you know, we try to, in a case like Barry, we do try to provide the storm surge guidance when we need to. Again, the storm surge information we provide publicly is generally accounts for a lot of forecast uncertainty. So it's a reasonable worst case scenario. So it accounts for that uncertainty in the track and if our intensity forecast is too low, for example. So it doesn't prevent us from providing that information, but there can be situations where the forecast may be more uncertain in those cases.
Okay, great, thanks. And you know, given the current state of hurricane forecasting and modeling, do you think that organizations like utilities that are a lot of utilities are members of the All Hazards Consortium, that they can expect, or what kind of forecast can they expect in the long term when they're trying to protect their infrastructure? A lot of utilities have critical infrastructure that are near the coastline, and those, you know, a difference of 1 foot or so in a storm surge or an inundation could really make a big difference. What is it reasonably that they can expect as a storm approaches?
Well, in terms of sort of high resolution information, the potential storm surge flooding map or inundation graphic does provide relatively high resolution storm surge potential at any one given location. Now, it's not an expected value. It's basically what the reasonable worst case scenario is. So that might be what they're interested in terms of their planning. It does use a smooth digital elevation map, so it might not meet their needs if they're in an area with a lot of topographical variation or elevation variation. But if they have specific questions, they can certainly reach out to NHC. And if they know the exact elevation of the site they're interested in, for example, in NAVD 88 vertical datum, we can do that conversion for them and provide them some information and help them understand sort of what value they would be interested in there. So yeah, there is information out there. But again, NHC doesn't provide high resolution forecast of storm surge. It's sort of more of a planning tool, what could happen at any one location.
Sure. Gotcha. Thank you. And another question about, I just want to give everybody with the All Hazards Consortium an idea for the number of people that actually work there at the Hurricane Center. So during the season, I guess you work in shifts, or do you up the number of people that work when a storm forms? Can you just give everybody an idea for how many people are there supporting the American people?
Sure. Yeah. Thanks, Dave. Yeah, we do work forecast shifts, rotating shifts, typically starting May 15th when the Eastern Pacific season starts, all the way through November 30th. And we have 2 folks scheduled for every shift. We have a day shift, an evening shift, and a midnight shift. But because our workload can be pretty variable, depending, sometimes we don't have any active storms. Sometimes we might have 1 or 2 open ocean storms, and other times we might have multiple storms affecting land and lots of other systems going on. So we have the ability to really scale up our workforce. Sometimes we might even have 3 or 4 forecasters on shift at a given time, in addition to all the other folks that might be there to support things like storm surge forecasting, media interviews, other decision support services and briefings. So during a situation like a Florence or a Michael or a Dorian, we might have as many as 10 or 15 people on the forecast floor at any one given time when it gets very, very busy. But in terms of the folks making the forecast for my branch, it's typically 2, but we can bump that up if we need to.
Great. And one other question that I had, when you were giving your presentation, you were talking about the sort of scenarios or cases for Dorian. If it encountered land in Hispaniola, if it just brushed, Puerto Rico, or if it missed land totally. When you're talking about rapid intensification, do you have the ability to, you look at all the models, and then, if you say, hey, we really don't think it's going to interact with land, does that thinking for the forecaster go into like the storm surge modeling and those predictions? So if you think that storm is going to go in a different direction, it's reflected in all of those subsequent products.
Yeah, so what we do is, we were looking at all the models, but then the human is still making the track and the intensity and the size forecast for the storm. So for example, if most of the model guidance is showing a track over land, but we think the track is going to remain over water, then we would make a track and an intensity forecast that's consistent with that thinking. And then that certainly would play into and be used as input into the probabilistic storm surge guidance. Now, it might take into account the fact that the storm could move over land, even if that's not in the explicit forecast, but that would then be captured in the uncertainty information that the probabilistic modeling provides.
Great. Thanks so much. And the final question really is one about Weather Service's Weather Ready Nation. When you talk about the goals of the Hurricane Center, what are those goals to help everyone become weather ready?
Well, it always goes down to preparation and awareness of your risk. The thing we preach every year is people have to be ready as if they're going to be affected by a storm every season. If you live in a hurricane-prone area, regardless of what the seasonal forecast says, or regardless of what happened last year or 5 years ago, or what's happened in the last 20 years, if you're in a vulnerable area, you still have to prepare. And you have to know if you live in a storm surge evacuation zone, or if your property's in a storm surge evacuation zone. That's going to be a very important decision point for your preparation plan. Might you have to actually leave your residence or leave your place of business or evacuate your employees away from the water? And if you're asked to do so by local emergency officials. And so again, have that plan in place, develop it now ahead of hurricane season, so that you're not putting a plan into place as a storm approaches, and because that can get really chaotic and cause a lot of stress that you can maybe mitigate if you plan for that now. Understand what your risk is. For some of your folks on the webinar that are utilities or other companies, you can always look at the storm surge risk mapping that's on NHC's website. We have high resolution storm surge risk mapping for the entire U.S. coastline that can tell you, what's your worst case scenario for storm surge in your area in a Category 5 hurricane? How much water could you potentially be dealing with? And that can serve as a very basic level of planning for what you might need to get ready for.
That's great, Mike. I really appreciate your time that you've taken today, and hopefully this webinar will really be of benefit to all the members of the All Hazards Consortium, particularly those that are living up and down the coastline. And remember also, for those of you in the All Hazards Consortium as members, once the hurricane makes landfall, there's a lot of inland flooding issues too. So I'm sure you all realize that. So Mike, thanks so much for joining us, and we really appreciate all the work that men and women of the National Hurricane Center do down there in Miami.
Thanks, Dave. We appreciate the opportunity and the partnership. Take care.